Okay, chemistry and integrated kids. This is the second screencast of this unit. Be another kind of short one. It will follow up the classification of changes in properties, and now we're going to look at the classification of matter. FYI, I'll be using a lot of this vocab, particularly from this side of the list. So if you've not already done that assignment to get the definitions of that vocab, that's something that you need to do first before going any further. I'll start here with kind of a flow chart that I like because it's nice and pictorial, that breaks it down all the way from matter at the highest level down to elements, compounds, homogeneous mixtures, and heterogeneous mixtures. The first division is between pure substances versus mixtures. Pure substances include things that only consist of one kind of atom or one kind of molecule. Now, molecules may be made up of more than one kind of atom, but the difference between those and mixtures is that in molecules, the different kinds of atoms are chemically bonded to each other, as in the case of water, the oxygen and the two hydrogens are chemically connected to each other, and not simply in the presence of each other, as in the case of a mixture, which is made up of more than one kind of atom or molecule that aren't chemically connected to each other, that are just sort of mixed together in ordinary physical ways. Okay. Our pure substances we can further divide into elements and compounds. Elements, if you notice, contain only a single kind of atom, whereas compounds, as we talked about in the case of water, or here in the case of methane, contain bonded atoms of more than one element. So that's how that you will tell elements apart from compounds. A compound contains more than one element. Now, something that we will come back to on the next slide that's kind of shown nicely here. This is a helium atom. It's an element because if it's a single atom, it can only be one kind of element. It has no other choice. This is also an element, but it does consist of two atoms bonded together in a molecule, but it's an element because both of the atoms happen to be the same element, in this case, two chlorine atoms. This is a molecule also, but it's not an element because it contains one carbon atom and four hydrogen atoms. So, one thing we'll show on the next slide is atoms are all elements. They have to be. Molecules, though, can either be a compound or an element. Okay? Coming over to wrap up on this slide, the mixtures. We can have homogeneous mixtures and heterogeneous mixtures. A homogeneous mixture is things like solutions, salt water, sugar water, Gatorade, that are so uniform in their composition, they've been mixed up so well that you can't visually see the different parts of the mixture. Heterogeneous mixtures, on the other hand, in this case, water and sand, are non-uniform in their composition. They don't mix up so well. You can still see the individual parts separately. So lastly, before I go on, I'll just add a few other examples to our list here. Elements are easy. They're anything off the periodic table. So if it's on the periodic table, it is an element. Compounds are going to be composed of more than one thing off the periodic table. So we said water, we've said methane, we could add rust because that's a compound of iron and oxygen. Maybe we could add various things like sugar. That's a compound of carbon, hydrogen, and oxygen. And anything, and this will be a clue even if you don't know what it is, if it has some kind of specific chemical name, that's me trying to tell you that it's a pure substance, that it contains only one kind of atom or molecule. So if you see a chemical name, think pure substance. If it's on a periodic table, then you know it's an element. If it's a chemical name that's not on the periodic table, then it's going to be a compound. Homogeneous mixtures, anything that dissolves, so sugar water, salt water. But also some confusing things like mixtures of metals. So I might say bronze, 18 karat gold or 14 karat gold, any gold less than 24. These, a lot of people confuse things like the bronze and the 18 karat golds for compounds, but they're actually mixtures, because if you sell your gold jewelry to a pawn shop, they're going to melt that down so they can separate the pure gold from the other things. So it's actually a mixture that you can separate by melting. So be on the lookout for things like that. If it's a mixture of metals, it's probably a homogeneous mixture and not to be confused with compounds. Lastly, heterogeneous, anything that you can see visual differences in. So wood, because you've got the light and the dark rain. Soda, because you've got the liquid part and you've got the bubbles. Italian salad dressing, anything like that where you can visually see different parts. On the last slide here, I'm going to draw a Venn diagram to maybe help you further with this if the flowchart wasn't quite your cup of tea. So I'm going to start with all matter. So that's everything. Sorry, I'm accidentally touching the top of the screen, getting that arrow in there. That matter we can divide into homogeneous and we can divide it into heterogeneous. And there isn't anything that could be both homogeneous and heterogeneous, so I've drawn these two parts of my diagram separate. Either it is to the point that you cannot distinguish differences between the parts, or you can. Okay. Mixtures, as we've talked about on the previous slide, can either be homogeneous mixtures or heterogeneous mixtures. So I'm going to draw my circle of mixtures, and it's going to encompass both, because we have some mixtures, Kool-Aid, Gatorade, salt water, that are homogeneous mixtures, some mixtures, salad dressing, soda, that are heterogeneous. Now my pure substances are made of only one kind of material. So every part is going to look exactly the same because they have only one kind of part in them, unlike mixtures, which means pure substances are contained entirely inside of homogeneous. I like to do this on the Venn diagram because as much as I like that previous flowchart, it doesn't address the fact that all pure substances are kind of by definition homogeneous. I'm going to zoom in here and we're going to subdivide our pure substances a little bit more. The two kinds of pure substances that you saw on the previous slide is we have elements and we have compounds. So we have things that are made of one element and things that are made of more than one element. As we saw, if you are an atom, a single solitary atom, you have to be an element, because an atom can only be one kind of element. Molecules, on the other hand, could be both. Because we have some molecules, like we saw in the case of Cl2, it's a molecule because it's more than one atom, but both atoms were of the same element, so that molecule is also an element. But we have other molecules, like water, H2O, and methane, CH4. They're molecules because they're more than one atom, but they're compounds because they're atoms of different elements. So be careful with that. All atoms are elements, but not all molecules are compounds. Some molecules might also be elements. So I'll just zoom back out so you can see all of this, and we will leave it for there. Thanks, guys. Hope this helped.